all the possible units and dimensional formula of chapter number 2. First one is electric potential. Electric potential. It is indicated as V, and V is equal to KQ by R. This is the formula. One more formula. V is equal to integration E dot dl. Now let's see the unit. See, electric potential, if we see the basic definition of electric potential is work done per unit positive charge. Work done in bringing a unit positive charge from infinite to a point inside electric field against the electric field is called electric potential. So basically, electric potential is work done per unit positive charge. Well, let's see the unit. See, the unit of work is joule. Unit of charge is coulomb. So joule per coulomb is the unit of electric potential. This joule per coulomb is called volt, from the name of scientist volt. Now let's see this dimensional formula. See, if joule per coulomb, the dimensional formula of joule is m1L2 T minus 2 by coulomb. The dimensional formula of coulomb is A1 T1 in terms of ampere. This will become m1L2 T minus 3 A minus 1. This is the dimensional formula of electric potential, that is volt also. Now, if coulomb is taken as a base quantity, then this will become joule per coulomb will become m1L2 T minus 2 divided by coulomb. It is taken as Q1. This will give m1L2 T minus 2 Q minus 1. This is minus 1. Okay. Electric potential energy. Electric potential energy. Although we know the unit of electric potential energy, but let's revise some formulas also. Electric potential energy is given by the formula U is equal to VQ. One more formula, U is equal to KQ1 Q2 by R. The unit of energy is joule. In terms of CGS, we can also say it is erg. Its dimensional formula of electric potential energy is m1L2 T minus 2. Dielectric strength. See, this is actually the strength for which the breakdown occurs in an atom. Suppose imagine if this is a non-polar molecule. This positive and negative charge are very near to each other. If it is kept inside electric field, if we keep this inside electric field, like if this is capacitor, this is positive terminal, this is the negative terminal. If you keep this inside, then it gets elongated like this. This is called polarization. Okay, see, actually this positive is made with the help of a battery, and this is negative. Now if you increase the voltage, then we can say the polarization will also increase. At some point, this dielectric breakdown occurs in the atom. Okay, this atom which was getting polarized, the negative and positive terminal will break apart. That strength up to which it can withstand is called dielectric strength. So dielectric strength is actually the electric field which is applied to break down the atom. So dielectric strength is nothing but electric field. It is electric field for which the dielectric breakdown occurs. We can say it can withstand that point. Electric field is given by the formula force acting per unit positive charge. So its unit will become F by Q. Force means Newton, Q means Coulomb. So Newton per Coulomb is the unit of dielectric strength. Also, if we multiply it with meter and meter, Newton into meter by Coulomb into meter, value doesn't change. This Newton into meter is called joule. So this will become joule per Coulomb meter. This joule per Coulomb is called volt. We can say this volt per meter. Now let's see its dimensional formula. See, dimensional formula of electric field is, you can say it is F by Q. Force, the dimensional formula of force is m1 L1 T minus 2. The dimensional formula of charge is Q1. That gives m1 L1 T minus 2 Q minus 1. Now if the charge, if the dimensional formula of charge is taken to be A1 T1, then we can get E is equal to F by Q. That gives M1 L1 T minus 2 by A1 T1. This will give M1 L1 T minus 3 A minus 1. Electric susceptibility indicated as chi. If it is for electric, we can write chi E. See, remember, whether it is electric susceptibility or magnetic susceptibility, both are unitless and dimensionless. Okay, so anywhere an MCQ is there asking for unit and dimensional formula of susceptibility, the answer will be M0, L0, T0 and unitless. So chi E is defined as polarization per unit electric field for a given permittivity epsilon 0. So if you put all the units of polarization epsilon 0 and E, will get it is a unitless quantity. This is unitless and dimensionless. Here P is polarization. This polarization is defined as electric dipole moment, that is 2aq, electric dipole moment per unit volume. See, this 2a is meter, this 2a is the distance between two charges, therefore it will be in terms of meter. V is volume. So polarization becomes, we can say it is coulomb per volume means meter square. So basically the unit of polarization is coulomb per meter square. Now let's see epsilon 0 E. Let's break down this thing. Epsilon 0 E. See, we know that according to Gauss law, phi is equal to E into A is equal to sigma q by epsilon 0. You remember this thing? Now if I take epsilon 0 here and A here, we get epsilon 0 A is sigma q by epsilon 0. It means the unit of epsilon 0 A is coulomb. Sorry, this will be area here. This will be area. Yes. So the unit of epsilon 0 A is equivalent to coulomb per meter square. So see, the unit of polarization here, it is coulomb per meter square. So polarization is coulomb per meter square. Epsilon 0 A is also coulomb per meter square. So therefore chi E is a unitless and dimensionless physical quantity. I hope you understood. Next, polarization. Polarization is defined as electric dipole moment. Electric dipole moment per unit volume. This is moment, electric dipole moment per unit volume. Now this electric dipole moment is 2aq, volume is V. Now this 2a is the distance between two charges in electric dipole, therefore we can write its unit will be meter. This is coulomb, we will write coulomb into meter by meter cube. That will give coulomb per meter square. So coulomb per meter square is a unit of polarization. Now let's see its dimensional formula. Coulomb per meter square. This coulomb gives A1 T1 meter square, and this is L2. We'll get A1 T1 L minus 2. If charge is taken as a base quantity, again coulomb per meter square, this will become Q1 by L2. We'll get L minus 2 Q1. So remember, the unit and dimensional formula of polarization is equivalent to sigma, that is surface charge density. Okay, so if it's surface charge density or polarization, both will have same unit and dimensional formula. Let's see line integration of electric field. Line integration of electric field. See, line integration of electric field is integration E dot dl. This is the line and this is integration. Okay, this is line and this is integration of electric field. So line integration of electric field is integration E dot dl. Unit and dimensional formula will be same as that of electric potential. So we know that electric potential V is equal to work done per unit positive charge. So therefore the unit of this will become joule per coulomb, which is also called volt. Its dimensional formula will be, see, this is joule per coulomb. Joule means m1l2t minus 2. Coulomb means a1t1. So this will become m1l2t minus 3 a minus 1. Then if the coulomb is taken as a base quantity, we can also say this joule per coulomb. Joule means m1l2t minus 2 by coulomb means q1. This will become m1l2 t minus 2 q minus 1. Energy density of electric field. See, energy density, it is rho E. Energy density of, see, whether it is energy density of electric field or energy density of magnetic field, the unit always will be that of pressure. Okay, pressure, stress, Young's modulus, energy density, electric energy density or magnetic energy density all have same unit and dimensional formula. So rho E is 1 by 2 epsilon 0 E square. This is the formula for energy density of electric field. Actually, this is the energy stored inside a capacitor. The energy stored between two plates of capacitor. If we divide the volume of capacitor by the energy stored here, if this is a capacitor, the total energy stored is suppose U. If we divide this energy with the total volume of the capacitor, we will get electric energy density. So rho E is equal to 1 by 2 epsilon 0 E square, that is U by V, energy stored per unit volume. Its unit I said, it's same as that of pressure. Let's see, let's derive. See, U by V, rho E is equal to U by V. V is volume. This is energy. Energy is joule per. Volume means meter cube. See, joule is actually Newton into meter. And this meter cube, let's write like this only, meter cube. Look at this will be Newton per meter square. So this becomes the force acting per unit area. See, remember, Newton is a unit of force, meter square is a unit of area. So this becomes force per unit area, and this force per unit area always gives pressure. So its unit, see, Newton per meter square is also called Pascal. Though we are not writing energy unit of energy density as Pascal, but we can relate to Pascal as well. Now its dimensional formula rho E is Newton means m1 l1 t minus 2 by meter square means l2. This will become m1 l minus 1 t minus 2. Okay. So some formulas were left behind in chapter number 1. Those were linear charge density, volume charge density and surface charge density. Let's see linear charge density. Lambda is equal to Q by L. Charge per unit length is called linear charge density. Unit of it will be coulomb per, length is meter. Its dimensional formula will be coulomb means A1 T1, meter means L1. This will become A1 T1 L minus 1. Next is surface charge density. Surface charge density. It is indicated as sigma. Sigma is Q by A, charge per unit area. Charge is coulomb, area is meter square. So its dimensional formula will become A1 T1, charge is A1 T1 by area is L square. So this will become A1 T1 L minus 2. Similarly, volume charge density. Volume charge density, rho is equal to, it is charge per unit volume. Charge means coulomb, volume means meter cube. So coulomb per meter cube is a unit of volume charge density. This dimensional formula will be A1 T1 by meter cube means L minus 3. So dimensional formula will become A1 T1 L minus 3. If charge is taken as a base unit, we can write Q1 by, this is L plus 3. Yes, Q1 by L3. This will become L minus 3 Q1 if charge is taken as the base unit.